Hello, welcome to my video. This is Kinley Jr. and here is my laboratory exercise for integrated programming 1. Good day everyone. In this video, I will discuss a simple project about system integration using text store inventory system. The goal of this project is to demonstrate how two independent subsystems can be connected using data integration. You will see how data is provided by one subsystem and how is it consumed and displayed by another subsystem. I will explain the concept, show a working demonstration, discuss the challenges that I've encountered, and relate the experience to real-world system. So now, let's start with an overview of the system component. This system is divided into two main components, subsystem A and subsystem B. Subsystem A functions as the data provider in my project. This subsystem is represented by a JSON file that stores structured information about various tech products. Each product follows a consistent structure including an ID, product name, category, brand, availability status, price, and stock quantity. Subsystem A does not handle display logic or use interaction. Its sole responsibility is to store and provide accurate and well-structured data that can be consumed by the other systems. Subsystem B acts as the consumer subsystem. It is implemented as an HTML-based interface that reads data from the JSON file and displays it as store inventory layout. This subsystem focuses on representing the data in clear and user-friendly way similar to an online actual text store or inventory dashboard. So now, let's move on to the integration model. The integration model was used in this project is data integration. This model was selected because subsystem B directly consumes structured data from subsystem A in the form of a JSON file. There is an actual flow of data between the two subsystems rather than static or hard-coded values. This approach closely reflects how modern systems exchange information using standard data formats. Now let's move on to the demonstration. For the demonstration, we begin by examining subsystem A. The JSON file contains a list of tech products such as laptops, monitors, keyboards, mobile devices, and networking equipment. Each product entry follows the same data layout, ensuring consistency across the dataset. Next, we move to subsystem B. When the HTML page is opened through local server, it reads the JSON data and dynamically generates inventory cards for each product. The system displays important information such as product name, brand, category, availability status, price, and stock level. If we modify the JSON file, for example, updating the stock quantity or availability status, and refresh the page, the changes are immediately reflected in the interface. This confirms that the system is using real data integration rather than static presentation content. Now let's proceed to the reflection. During the integration process, several challenges were encountered that are common in real-world systems. Firstly, we have data format mismatch. If the structure of the JSON file did not exactly match the consumer subsystem expected, the inventory failed to display correctly. Then we have structural dependency. The consumer subsystem depends heavily on the consistency of fields names such as price, stock, and status. Any changes to these fields require updates in the consuming logic. Let's go to the real-world applications. This project closely mirrors real-world integration scenarios. Retail platforms use similar data integration methods to synchronize inventory between warehouses and online storefronts. Financial systems integrate transaction records across multiple services to ensure accuracy and compliance. HR and enrollment system also integrates employee or user data across payroll, attendance, and access control platforms. In all these cases, reliable data integration is critical to ensure data consistency and operational efficiency. So now, let's proceed to the conclusion. So, in conclusion, this project demonstrates how data integration allows independent subsystems to work together using structured data. By separating data management from presentation, the system becomes easier to maintain, update, and scale. This project highlights the importance of proper data structures, validation, and integration planning in real-world software systems. Overall, the project successfully demonstrates a practical example of data integration using text store inventory system.